So in the previous few videos, we have been talking about progressive wave, or as we call it, traveling wave. So these kind of wave, you can see the wave pattern progress from one region of medium to another region of the medium, like it travels to the left or travels to the right. It's not that the particles is traveling to the left or the particles are traveling to the right. It's the pattern, the crest, the trough, the pattern, the wave pattern, it's traveling to the left or to the right. So for those kind of wave, we call it traveling wave. So now we are progressing to another kind of wave, which is standing wave, or another name is stationary wave. And now we'll be seeing how standing wave or stationary wave is related to the progressive wave that we have learned earlier. So now let's look at this video here. So this video here, it's produced by a YouTube channel called XM Demo. I highly recommend you all can go search it. There's many demonstration videos, especially for physics, in this channel. So a great shout out to XM Demo over here. So if you look at this video over here, try to observe what happened when the wave hits the end over here. So what will the person do is the person will be shaking his hand like this. So by shaking his hand like this, it will introduce a wave pulse, okay, means by one pulse of wave into the system along this medium here, which is a spring. Then after that, when it hits this end over here, try to observe what happens to the wave when you reach that end. Okay, so I will start playing this video over here. So you can see that is a fixed end. So when they send a pulse over, you can see that the wave pulse is being reflected. But now they have changed it to a loose end. So this is a string. So the end is able to move. Just now the end is fixed, but now the end is able to move. And I believe you see that the wave pulse is coming back at the same side of the rope. Okay, if it's a fixed end, it goes to the opposite side of the rope, opposite side of the string or rope, spring or rope. But if it's a loose end, okay, opposite side. Okay. If it's a loose end, then you can see that the wave pulse is coming back on the same side of the spring or same side of the rope. So this is what we call boundary condition, in which what's happening is when the wave encounter a boundary, what will happen to the wave? It will get reflected back in the opposite direction, traveling through the medium as well. Okay, so this is just a demonstration video. Why is this video important? Because it tells us that progressive wave gets reflected when they reach a boundary. So the boundary is either a fixed end or a loose end. The main point is if we reach a boundary, it will get reflected. Okay, so why is it important? So progressive wave gets reflected when they reach a boundary. So it can be reflected in the opposite direction. In this case, this is a fixed end. Or it can be get reflected, but the pulse still remain on the same side of the medium. So that one is a loose end, in which the end here is able to move. Loose end. This one, the end is always remaining at its place over here. This is not exactly in your syllabus, but it will help you understand how standing wave is being formed. Okay, it's quite important here. So if there is no energy loss, we can assume that this reflected wave here, the wave that is coming back in this direction, the wave coming back in this direction here, should have the same amplitude, same angular frequency, and the same wave number as the incident wave. So this is the incident wave, this is the reflected wave. And if there is no energy loss, you should expect that they have the same amplitude, the same angular frequency, and the same wave number. So this is the amplitude of the incident wave. Now, if you look at the reflected wave, it has the same amplitude as well. And the omega, you can see that the wave is traveling here in this speed, traveling back in the same speed as well. If the incident and the reflected wave have the same speed, then you can know that the omega and the k should be not changing, okay? Because omega divided by k, you get the wave speed. The wave speed remain the same, so omega divided by k does not change. you see the wave doesn't get more packed or less packed, so you know the k is constant, therefore you know the angular frequency is constant as well. Okay, so the second main point is that the reflected wave have the same amplitude, angular frequency, and wave number as the incident wave. Okay, so we have mentioned two points already here. So now, what if we send another pulse, okay, while the previous wave pulse is reflected back towards us? Let's say now the wave is coming back towards us, right? What if we send another wave to the right when the reflected wave is coming to the left? Okay, so what if we send a wave pulse now? We send a wave pulse to the right. Then you interact with the reflected wave that is going to the left, right? So how does it interact? Let's try to look at it right now. So this is what will happen if your reflected wave travels back and you send an incident wave to the left. Okay, so if you look at it, now you see there's reflected wave being reflected to the left and you send with incident wave to the right. So the incident wave that you send to the right will interact with the reflected wave that is traveling to the left. And the result of the interaction is as what you can see here. You can see for quite a moment that there's some kind of wave that is pulsating in one region only. When it interacts together, I believe you can see that the wave is sort of like stagnant already. It's like this. It's not like this. It's stagnant at one position. So that you can see something that is stationary is being formed right now. Okay, by combining two waves that are traveling in opposite direction, you create a wave that is stagnant, that is not moving to the left, not moving to the right. Okay, for that little moment over here, like right now, see the wave is at the position like this. Okay, so what happens when you have two wave overlapping in one region here? There's something called interference happen. Okay, so interference occurs. So what is interference? Interference is the phenomena in which two or more wave passes through the same region at the same time. So this is what happens here. You have a wave traveling to the left, you have a wave traveling to the left, you have a wave traveling to the right, and both of these waves are overlapping in the same region of the medium, in which they are overlapping right now at this region over here. So when two or more waves overlap, interference happens. Interference is the phenomena, it's the occurrence. When you see two waves overlap, interference happens. Okay, so now what if we continuously send a progressive wave while the same progressive wave is reflected back towards us? So now I send two pulses only, right? You see here, I'm only sending two pulses only. But what if I don't stop? What if I continuously shake the rope so that the wave is continuously traveling to the right, while at the same time the reflective wave is continuously traveling to the left? So now I don't make it two times only. I continuously shake my rope so that the wave is traveling to the right, at the same time the reflected wave is traveling to the left. Then what will happen? Let's try to think about it. So now I'm continuously shaking my hand like this. I'm shaking my hand up, down as what my laser pointer do. So because I shake my hand, then there's a progressive wave traveling to the right. So this wave here is produced by me shaking one end of the rope. And because this wave here is traveling to the right, therefore it's negative kx. So this is the first wave. But you know that this wave here will encounter one end. Okay, this is the one end that you are shaking. You know that you encounter another end. So you encounter a boundary. Okay, when you encounter a boundary, what will happen is you get reflected. So this is the wave that is reflected back from the boundary. It can be reflected in the opposite side of the rope or the same side of the rope, but that one is not our main concern. You just need to know that it gets reflected. Then the progressive wave is reflected from the boundary. And this wave here, we mentioned from our point number 2 that it has the same amplitude, same angular frequency, same wave number as the wave that we send to the right. Therefore, you should expect exact same equation, except that you change the negative sign to positive sign, because now this wave is traveling in the opposite direction towards the negative direction, which is to the left. Okay, so these two waves here will overlap on the same region of the rope. These two things is happening on the same rope, but you won't see both of this. You see a combination of this wave and this wave. And as we see just now, the combination of these two waves will be a wave that is not going to the left and the wave is not going to the right. It's a stationary wave. And the result of the combination is something like this. So this is what you observe is if this wave is overlapping with this wave. So you will not see this wave on your rope. You will not see this wave on the rope. What you will see is just a combination of these two progressive wave over here. And this is the result of the combination. And as you can see, this wave here is not going to the left. This wave here is not going to the right. It is just a wave that is stationary in terms of its pattern. You don't see the pattern progress to the left or progress to the right. So this kind of wave, we call it a standing wave. Standing means not moving, just standing there. Or we can call it a stationary wave. Stationary means at rest, right? So it's not moving to the left, not moving to the right. Stationary wave. So the main characteristics of a stationary wave or a standing wave is that the wave profile does not. So wave profile is a wave pattern. You see the crest doesn't move to the left, the crest doesn't move to the right. The trough doesn't move to the left, the trough doesn't move to the right. If you look at traveling wave, you can follow the crest is progressing to the right. You can follow the crest is progressing to the left. But this is not the case. This is a stationary wave. The pattern does not travel. Okay, so now this standing wave here is formed due to the interference of two identical progressive waves traveling in opposite direction. So you know that this standing wave here is formed due to two progressive waves overlapping together, and these two progressive waves are traveling in opposite direction. So this is how you create a stationary wave. So now here I'm going to show you a demonstration again by XM demo. So here this demonstration here will show you how to create a standing wave on a rope here. In this case, this is actually a spring, a very long spring. But here, this person here is going to demonstrate how to create a standing wave. So let's play this video and see. As you can see, the hand is moving left and right here. So what is he doing here is he's sending a progressive wave towards the fixed end, and the progressive wave is reflected back, and the result of the combination of two progressive waves is what you see in the video right now. So this is what we call first harmonic just now, and this is what you call a second harmonic. Okay, you can see there's 1, 2. Okay, second harmonic. You can see there's one note in the middle. This is second harmonic. Now you'll be trying to do a third harmonic. Now when you see there's a third harmonic, you see that there'll be two notes here. So there'll be 2 points that are not moving. Note, 2 points that are not moving. So this is third harmonic. We'll learn about harmonics in the future videos where we discuss standing wave. But for now, you can see this is how we produce a standing wave. We shake our rope at one end, let the progressive wave travels to the fixed end, then let it reflects back. And the result of the incident wave and the reflected wave, they combine together, then you result in a stationary wave. And this is what you observe on the rope. Okay, so this is how you create a standing wave. And in the next video, we'll be talking about the equation for standing wave, and we'll try to understand the properties or the characteristics of standing wave.